Chapter 5. The Scientific Method, Born from Doubt. Because one good question is worth 1,000 assumptions, it's easy to romanticize science as a beacon of clarity in a chaotic world. But let's not forget that it owes its existence to a much humbler and far messier source: doubt. The scientific method is not some pristine system handed down from the heavens. It's more like a scrappy toolkit built over centuries by people who looked at the world and said, "I'm not so sure about that." It's skepticism turned into action, a process designed to sort truth from fiction with the intellectual equivalent of a magnifying glass and a pair of tweezers. If doubt is the fuel, the scientific method is the engine. It doesn't just let us question the world, it shows us how to do it in a way that actually produces answers, most of the time. But before we dive into how the scientific method works, let's take a quick detour to appreciate where it came from and why it matters. A brief history of asking what if. The scientific method didn't spring fully formed from the mind of a single genius. It's the product of centuries of trial, error, and, let's be honest, some pretty weird experiments. Early philosophers like Aristotle believed they could deduce how the world worked purely through reasoning. This was a great system for coming up with ideas, but it also led to some hilariously wrong conclusions. Case in point, Aristotle thought heavier objects fall faster than lighter ones, an idea Galileo literally dropped to the ground centuries later. The real game changer came during the Renaissance, when thinkers like Copernicus, Galileo, and Francis Bacon decided that maybe we should test our ideas instead of just assuming they're true. This shift was revolutionary, not just because it produced better results, but because it embraced the radical notion that humans could be wrong. The scientific method is, at its heart, a process for being less wrong over time. Step 1. Ask a good question. It all starts with curiosity. Why do apples fall from trees? What makes the stars shine? Why does bread always land butter side down? Okay, maybe not that last one. The point is, the scientific method begins with a question, one that's specific enough to investigate but broad enough to matter. A good scientific question is like a key. It opens doors. It's not about finding the easiest answer. It's about finding the most meaningful one. This is where skepticism comes into play. Instead of accepting the first explanation that comes along, scientists push deeper. They ask, is there more to this? Is this really true, or does it just seem true? Step 2. Form a hypothesis, but don't get too attached. Once you have a question, the next step is to make an educated guess, a hypothesis. This is where things get tricky, because humans are naturally inclined to fall in love with their own ideas. But in science, a hypothesis is not a hill to die on. It's more like a testable hunch, something you're willing to abandon if the evidence doesn't support it. This is why skepticism is so crucial at this stage. A good scientist approaches their hypothesis the way a detective approaches an alibi, suspiciously. They know that it's not enough for an idea to sound good or fit neatly into their worldview. It has to hold up under scrutiny, and that means being willing to poke holes in it, even if it's your own pet theory. Step 3. Experimentation, a fancy word for let's see what happens. This is where the magic, or more often, the tedium, happens. Experiments are the bread and butter of the scientific method, designed to test hypotheses in controlled ways. The key word here is controlled. Scientists don't just throw ideas against the wall to see what sticks. That's what brainstorming sessions are for. Instead, they carefully design experiments to isolate variables, minimize biases, and produce reliable data. Of course, experimentation isn't always glamorous. For every eureka moment, there are countless hours spent measuring, observing, and muttering, "That's weird," under your breath. But this is also where skepticism shines. A good scientist doesn't just look for results, they look for patterns. They repeat experiments, double-check their work, and consider alternative explanations. Why? Because they know that the first answer isn't always the right one. Step 4. Analyze the data, without cherry-picking. Once the data is in, it's time to make sense of it. This is where skepticism has to work overtime, because humans are natural pattern seekers. We're so good at spotting patterns, in fact, that we often see them where they don't exist. Hello, constellations. You're just random stars, but we decided you look like a crab, so here we are. A skeptic looks at the data and asks, is this real, or is it just a coincidence? does it challenge it? They also know that negative results are just as important as positive ones. If your experiment doesn't confirm your hypothesis, that's not failure, it's progress. It's one less wrong idea in the world. Step 5. Share your findings. Brace for criticism. Science isn't a solo sport. Once a hypothesis has been tested and analyzed, it has to be shared with the wider community. This is where peer review comes in. A process that sounds polite is actually more like intellectual gladiatorial combat. Other scientists will scrutinize your work, replicate your experiments, and point out any flaws they can find. This might sound harsh, but it's how science improves. Skepticism is baked into this process. It's not enough for one person to say, "I figured it out." The scientific method demands consensus built on evidence, not authority. That's why even the most groundbreaking discoveries are treated with caution until they've been rigorously tested by multiple people. Doubt is the foundation of progress. The scientific method isn't perfect. It's slow, messy, and often frustrating. But it's also the best tool we have for understanding the universe, because it's rooted in doubt. It assumes that we don't have all the answers, and that's a good thing. Every new discovery is just one step forward in an endless journey, and skepticism is the compass that keeps us moving in the right direction. So, the next time you're tempted to trust a flashy headline about scientists proving X, remember this: good science doesn't prove, it questions, tests, and refines. The truth isn't a destination, it's a process. And it all starts with one simple, skeptical question: what if we're wrong? Footnote: scientists have yet to definitively explain why toast lands butter side down, but if you ask them, they'll probably suggest an experiment involving slow-motion cameras and a very large breakfast.